students, welcome to RECTV. This is Kalyan and I'm faculty of Mathematics and Physics. So in this class, we are going to discuss one more application based on converse of Thales theorem.
Please subscribe and don't forget to click the bell icon for the more updates.
Before going to start this problem, let me tell you what is the result of converse of the Thales theorem. The line which divides the two sides of the triangle proportionately will be parallel to third side. That is what converse part. Okay. Anyways, so here I don't want to read this entire question. I will show you diagrammatically so that it can be easily conveyed. And before starting up this problem, I want to tell you that this is the question of CBSE board exams 1995, 96 and 2005, 2002, and once again also it might be repeated. Take care of this. Okay. So anyways, now this in this question we have given a triangle DEF and X is an interior point which is considered as it is mentioned in the question. Okay. Now from X we have joined the three distances or three vertices. See here, D is also joined here, E is also joined here, F is also joined here. So that means XD, XE and XF are the distances, are the lines joined from that interior point X to all the vertices DEF. Now this XD, XE, XF lines are separating this bigger triangle into three small triangles. What are those triangles? Let us figure out. Okay, XDE and XEF and XFD. Three triangles are given, and we are mentioned that here PQR are the points on XD, XE, XF. Okay, here we have given that PQ is parallel to DE and QR is parallel to EF, and we need to show that PR is also parallel to DF. That means this is also parallel to this. So here we need to take the advantage of take the advantage of Thales theorem as well as its converse also. Just let me look at this. Now you can observe the first triangle XDE. Okay, if you are unable to observe this, let me draw this separately here. Okay, this is X, this is D and this is E. Okay, this is XDE triangle. Now as I said that PQ is drawn parallel to DE. PQ which is drawn parallel to DE. Like this we have drawn. Now here clearly we can see this this condition is flexible to apply the Thales theorem, because here PQ, one line which is drawn parallel to the third side, then obviously it will we can apply Thales theorem result. What is that? XP by PD equal to XQ by QE. Okay, that is what the result of Thales theorem. So let us write down the proof. Okay, here in triangle what? XDE. In triangle XDE. Okay, what can we say here? XP by PD. XP by PD equal to XQ by QE. That means XQ by QE. Okay, XQ by QE. This is what the result of Thales theorem we can apply for this first triangle. Let this condition be 1. Okay, this condition be 1. Now let us consider the second triangle, that is XEF. Okay, second triangle would be what? XEF. That triangle is like this. See here, this is XEF. Let me draw here. Okay, XEF, and as I said that QR is parallel to EF. This is QR. These two are parallels. Okay, QR is parallel to EF. Got it? So now here also we can apply Thales theorem because the condition is favorable to that. what the condition we obtained? Here QR, a line which is intersecting both XF and XE, is parallel to the side EF. So therefore there are flexible conditions to apply Thales theorem. And what can we apply from this? In this triangle XEF, in triangle XEF, what can we say? Here from by the application of Thales theorem, XQ by QE, okay, XQ by QE equal to XR by RF. XR by RF. Okay, now let this condition be 2. Okay, now combining this 1 and 2, okay, the conditions 1 and 2, on combining them, what do we get? Here XP by PD equal to XQ by QE. XQ by QE equal to XR by RF. Here XQ by QE is commonly here and here. XQ by QE is commonly equal to two different expressions. So therefore those two expressions also will be same or not. So here from 1 and 2, what can we write? From 1 and 2, we can say that, okay, XP by PD equal to XP by PD equal to XR by RF. Okay, now after doing this, if you observe the third triangle, what can we say? Just look at the third triangle. What is the third triangle? XFD. See this XFD. If you observe this like this, understood? Like this, if you observe, this is X, this is F, and this is D. Now, here what we said, here there is no line drawn here. We just put a dotted part of the line, and now this is R, and this is what? P. From this, what did we obtain? Just tell me here. We obtained XP by PD equal to XR by RF. Observe, XP by PD equal to XR by RF. That means here this dotted line PR, okay, this dotted line PR is dividing the two sides of this triangle proportionately, means in equal ratio. Okay, this XP by PD equal to XR by RF we obtained by automatically we obtained this. That means what? This PR is dividing XD and XF in the equal ratio. That means proportionately. So now can we apply the converse part of Thales theorem or not? Exactly. So we can apply here converse part of the Thales theorem. What does it say? Yes, when a line divides two sides of a triangle proportionately, will be parallel to third side. What is third side here? It is dividing these two sides proportionately. Then third side will be obviously what? FD only, na? Or DF or FD, whatever you say, this side. So that means depending on the converse part of Thales theorem, we can say that PR is also parallel to what? DF. So from this implies we can write, okay, PR is also parallel to DF. Here PR means this and DF means this. Understood? So from which part of the theorem we said this? From converse of Thales theorem. Thales theorem. Right? Like this we can show it. That means to show this we used two results. One is Thales theorem and second one is converse part of it to get the required part of the result. Understood? I think you might have understood this one. It's a very simple one. Two times we applied Thales theorem and third time we applied converse of the Thales theorem to obtain the result. Understood? So anyways guys, don't be panic after seeing these lengthy questions. These are very simple to solve, but you need to have the awareness towards the geometrical concepts. Don't worry, we are here to clarify you all. Okay, anyways, for today this is it.
Please subscribe and don't forget to click the bell icon for the more updates.